Hello students, and welcome to this lesson on solving rational functions. Our objective today is that we will solve examples of rational functions using 11-62 practice solving rational functions and also our journal notes. So our main method for solving rational functions is actually just a four-step process. Step one is that we find the common denominator. So if I take an example here of 5 over x plus 3 over 2 is equal to 4, and we want to solve for x, then that's the process that we'll go through here. So we need to find the common denominator. So I need to find a common denominator of x and 2. Well, if I factor them, they're not really factorable, so all I really need to do is multiply everything by 2x. So if I multiply every term by 2x, then I'll get 10x, because 2 times 5 is 10, over x, plus 6 over 2 is equal to 8x. However, I want to simplify this. So that's our third step. So we went from step 1, which was here, and then we multiplied everything, which got us here, and then now we're simplifying. So we simplify this, we see that x and x will cancel, and we see that 6 divided by 2 will just give me 3. So my new expression here will be that 10 plus 3 is equal to 8x. Then we'll see that we have 13 is equal to 8x, and therefore x is equal to 13 divided by 8. All right, and that's our process. Now, let's take that process and apply it to a few of our practice problems. So go ahead and pull out your worksheet, 11-62 for today, and we're going to work some of these practice problems. The first example that will work is number 1. All right, so we have this expression here, and it is x over 3 plus x over 2 is equal to 10. And we want to find the value of x. So first, step 1. We go back, we look at it, we say find the common denominator. So I need to find a common denominator for 3 and 2. Well, we look for the least common multiple, right, and that'll be 6. So what we'll do is we'll multiply everything by 6. So we say 6 times x over 3 plus x over 2. And then on the other side, we also have 10 times 6. All right, so now we have 6x over 3 plus 6x over 2 is equal to 60. Okay, so let's simplify this now, right? So we simplify, 6 over 3 is 2, so we have 2x plus 6 over 2 is 3 plus 3x is equal to 60. And we'll find that 5x is equal to 60. And so x is equal to 60 divided by 5, and x is equal to 12. All right, very good. Now our next problem. So we see that example number 1, relatively straightforward, and we'll actually see that number 5 is even easier. So I'm going to make an observation here in number 5. Number 5 looks an awful lot like a situation that we've seen before with cross multiplication, and actually that's going to be true. So really all I'm doing here, I'm still finding that common denominator, right, which will be 12. So I'll multiply both sides by 12. But ultimately, what ends up happening here is that the 4 and the 12 cancel each other out, and you're left with 3 on this side. And then the 3 and the 12 cancel each other, and you're left with 4 on this other side. So it's effectively the same thing as doing cross multiplication. So that's actually what we'll do here, is if you have a single fraction on each side, then you can cross multiply. So you get 3 times 3x is equal to 4 times 5x plus 1. And so you'll get 9x is equal to 20x plus 4. Then we'll subtract 9x and 4, so I'll say negative 4 is equal to 11x, and then x is equal to negative 4 divided by 11. So if we have a situation like this where we've only got one fraction on either side, then this is actually a really easy problem. This will also work for problems that have an expression in the denominator, right? So the same rule applies. If I've got my expressions down here, then all I'm going to end up doing is cross multiplication. So this is going to be number 9, and we say 4 times 2x minus 1 is equal to 10 times x plus 3. And so this is going to be 8x minus 4 is equal to 10x plus 3. And from here, we will find that, oh, I'm sorry, this is 10x plus 30, obviously, because we have to distribute to both. So then this will be 2x is equal to negative 34, and x is equal to negative 17. Now, it's also really important that we're able to use these skills to isolate variables, and that's what numbers 11 and 12, and I believe 13 are all about. They're about isolating variables. So, let's go ahead and take a look at this. What this formatting here means is that I'm looking at this expression, and what I want to find is x. So I want to get x by itself. All right. Well, we want to get x by itself. The first step to doing that is getting rid of the denominator. So we still want to solve this like a rational function. So I still want to find the common denominator and multiply everything by it. So I'm looking at everything that's in the denominator. I have an x, I have a y, so that's going to be the common denominator, is z times y. So I'll take the entire expression and multiply it by z times y. So over here I have z times y, and over here I have z times y. Alright, so let's go ahead and distribute. So we have z times x times y squared over z plus 2x times z times y is equal to, over here we're going to have z squared times y over y. Alright, and we notice that we have some things that will cancel out here. So we've got z and z will cancel, and then over here we've got y and y will cancel. So we're left with xy squared plus 2xzy is equal to z squared. Now this looks really messy at first, but we're going to see something will happen that will actually work out in our favor. So we notice that there's an x in each of these terms, correct? And x is what we want to get by ourselves. So what's really nice about this is that we will be able to factor out an x out of each of these terms. So we want to go ahead and factor out an x from each term, and we get x times y squared plus 2zy is equal to z squared. And now we can just divide both sides by this entire term, and we'll have x by itself. So we divide both sides by that term, and you get x is equal to z squared divided by y squared plus 2zy. And that'll be our answer. Alright, so those are our 4 examples right now. And we noticed that we saw 2 different methods for solving, right? We could either cross multiply, if we had a situation like this where we only had one fraction on either side and also there were no other numbers. So if you have a situation that looks exactly like this, you can cross multiply. And then we also saw where we have to match denominators and simplify. All right, so for your reflection, what are the two main methods for solving these rational functions? And then also tell me, what do you look for to tell you which method to use? So what are your key indicators that tell you which method to use, and what are your two methods? If you have any questions, let me know. Your assignment for today is to finish 11-2. So go ahead and get started on that. Let me know if you have any questions. Have a wonderful day. Goodbye.